Israel, access do now at 8:17. Sapphire has already turned do now in. Thank you. Brianna working on that do now. Eric is working on that. Trinity working on that do now. All right, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people working on the do now. Checking the chat. We got 22 people. Let me see everyone accessing that do now.
Is it the lesson 11 do now?
Just 2 minutes remaining. Lesson number 11. Thank you so much. All right, so remember the first 2 questions are review for lesson number 10. Hopefully everyone has turned that in. And then lesson number, the last question is your preview question. It's a heads up of what you should be able to answer by the end of the class. Refreshing one more time. All right. Almost 100% of us accessing that do now. Edward, let me see you join in. Emily, let me see you.
I just did.
Good. Let me refresh. All right, thank you. Looking for Emily to join in on that do now. If you're just joining in, we are now doing our lesson 11 do now. And we're submitting within the next minute. Before we begin, we want to identify any areas where we have some misconceptions, anything we want to clear up moving forward. Cynthia, let me see you accessing that do now. You have less than a minute remaining. In the last 30 seconds, you want to begin submitting your do now before we begin. Be prepared to jot down in your notes any misconceptions you may have and any clarifications we make. And it's now 30 seconds remaining. Please go ahead and hit submit. Edward has submitted. Sapphire has submitted. Antonia, Donald, Jacqueline, thank you for submitting. Refreshing one more time. All right, almost 50%. Isaiah, Trinity, Ashley, Jacqueline, Zaya, go ahead and submit. Edgar, Veronica, Hannah, Jesus, go ahead and submit. Refreshing one more time before we start to identify areas of misconception. We need 100% of us submitting. Guys, this is my temperature check to make sure we are not, so that I can capture any misconceptions so that you can see where you need to grow the most and where we need to focus on in this lesson to help you get caught up. Refreshing one more time. Need 100% submission, almost there. Still waiting on Isaiah, Trinity, and Ashley, and Zaya. Go ahead and submit, guys. And you can always access these do nows before class begins. Hannah, Jesus, Edgar, Veronica, please go ahead and submit. right, thank you so much. All right, let's review our first two questions or review questions for lesson number 10. Let's look at the statistics. That's how well we did. Let's identify any areas for growth. Looking at the stats, we said that 6.7% of us, 67% of us identified the correct answer for one. Let's do a quick review of this question. If arsenic has been found as a replacement for phosphorus in bacteria, what makes it a good substitute? All right, let's look at the response. Scrolling down to the bottom, here we have our answer. Arsenic is in the same column on the periodic table. All right, so very important to note, please write this down. Arsenic is in the same column. So you need to reference the column as well as the periodic table. Next, which means that it has the same number of valence electrons. All right, so are you saying, Mr. Sang, once they're in the same column, they have the same number of little dots surrounding them? Yes, that's what we're saying. The same number of valence electrons for all elements in the same column. Continuing, and can make the same number of bonds as phosphorus? Yes. Once elements are in the same column, they can make the same number of bonds because they have the same number of electrons. All right, for those who did not get this, we're going to be focusing on using a sentence frame that forces you to reference the periodic table and the column within that periodic table. All right, next question for review from lesson number 10. All right, so we found that we need to definitely identify some misconceptions here. On average, we're not doing so well. So let's see what the question is and let us review. So sulfur will make blank numbers of bond with hydrogen, but makes blank numbers of bonds with oxygen because it has more blanks than nitrogen does. All right, let's look at the responses. Blow this up a little bit. Scroll on down. Nice. All right, so listen up. Let's identify some areas of misconception. All right, please be ready to get these down in your notes. Sulfur will make 3 bonds. We identified that sulfur will make 3 bonds with hydrogen, but makes 4 bonds with oxygen because it has more protons than nitrogen does. All right, so sulfur will make 3 bonds with hydrogen, but makes 4 bonds with oxygen because it has more protons than nitrogen. Okay, so remember, we need to reference where sulfur is in the periodic table. Sulfur is found in group 16, right? But it's higher in the periodic table, so it's smaller. Notice that they say it's able to make 3 bonds. And pulling up a quick periodic table, just modeling for you, making sure that you guys are pulling up your Lewis dot diagrams, Lewis dot periodic tables. So make sure you have those periodic tables open. Those are your chemistry Bibles. Without your chemistry Bible, it's hard for you to pass this class. All right, so here we have oxygen, here we have sulfur. Oxygen is higher up in the periodic table. Sulfur is lower down. Sulfur has more protons than oxygen because it is bigger than oxygen. So it's able to have more bonds than oxygen. All right, guys. So that was our review. And for those who are concerned, we will build on this. And in your ed puzzle, I want you guys to identify how does the periodic table change as we go down the groups. All right, so look out for that in your ed puzzle that you will be completing before your exit ticket. All right, turning our attention back to our lesson for today. I want to pull your attention, as we said before, we need to make sure that we're referencing that periodic table. So find every opportunity to use this phrase according to the periodic table in column, and you're going to tell us which column. All right, I think there's a double thing here. So according to the periodic table in column so-and-so, you're going to tell me the number of valence electrons, and that will definitely make sure that you are adhering to the rubric and referencing the table as well as a column where the element is found. Go ahead and also write the vocabulary in your notebook, and go ahead and start to respond to your I can statement. Identify the most important things in your peer deck. I'm going to call upon a number of people. Make sure your backgrounds are free and ready. Cynthia, label for, could you state the first vocab term that you have written in your notebook? The first vocab term. All right, Cynthia going once, twice. Kaylee, name the first vocab term you will be writing in your notebook.
Symmetrical.
Thank you. And the popcorn.
Edward.
Polar.
Popcorn.
Is Jacqueline Padilla on?
Jacqueline Padilla.
Asymmetrical.
Thank you. Popcorn.
Ashley.
Times are going, guys. Times are going. Ashley. Popcorn Veronica.
Wait, do you want me to say one?
Yes, go ahead.
Bond.
Popcorn.
Hannah?
Hannah. Term you're writing down in your notebook. Go.
My what?
Your term from your vocab list.
Covalent.
Thank you so much. Popcorn.
Edgar.
What happened, mister?
Times are going, Edgar. Next term from your vocab list.
Wait, hold on. I can't see it because it's like blurry.
Okay. All right. So name one that has been.
I see it now.
Yeah, go ahead.
Asymmetric or what?
All right. So got that one. Give me another one.
Covalent.
Got that one. Go down the list.
State of matter.
State of matter. And what does that S, L, and G stand for? Could you think? Can you guess? States of matter.
No.
All right.
Is
Can
it solid,
anyone,
liquid, and gas?
solid, liquid, and gas. Thank you so much. And if we're talking about solids, liquids, and gases, we are going to focus a lot on melting point and boiling point. All right. So we have two people responding in our Peer Deck chat. Peer Deck, according to the periodic table. Thank you, Trinity. Jacqueline is second, using upper cases, using the academic STEM. Veronica, we know that. Israel, number 6, who's gonna be in the top 10? What will we figure out from this lesson? What did we figure out from the previous lesson? And for those who have not completed your IMT, what you write now for what we figured out is gonna be the best source of your information that you can use to enter into lesson number 10's IMT. Let's see what we figured out together. Thank you, Sapphire, what we figured out. Still waiting on 10 non-responders so far, using the terms substitute, elements. Thank you so much, Jacqueline. Israel using the term periodic table, referencing a specific column. Recall that someone is mentioning arsenic. Thank you so much, Veronica. What was the other element that we referenced? Where was arsenic found? Go ahead and tell me that. I can just imagine you looking back at your notes, your IMTs. All right, so it's beyond 10 seconds, still waiting on us to use the academic STEM and other sentence frames provided. Debriana, Antonia, Kaylee, Jacob, Edward, Ariana, Emily, and Donald. I think something we figured out. Thank you so much, providing that sentence frame. Edgar mentioning arsenic. Almost 100% still waiting on 6. And time is of the essence. We want to make sure that you guys are free to use your asynchronous time to complete your Edpuzzle student assessment sheet and exit ticket. Hey, Veronica, could you share with us what we figured out from the previous lesson?
I said that we figured out that Arkansas can replace I don't know how to pronounce it.
That pH
Phosphor-
makes that.
yeah,
That,
that.
English language is so funny. PH makes the F sound. Can you imagine that? It's arsenic and phosphorus. Thank you so much. Isiel, I noticed that you mentioned a specific column. What column and why?
I picked 15 because that's where arsenic and phosphorus are located at on the periodic table.
Is it 15, 13 or 15?
I don't remember. I thought I was 15.
15. I thought I heard you said 13. Just to clarify, so you said 15. Thank you so much. All right, so how many valence electrons then?
I think they have
Looking at your periodic table that you pulled up.
And it's because I deleted the tab.
All right, all right. So looking for the first person to identify the number of valence electrons.
Yeah, 5 electron. Wait.
Thank you so much. 5 valence electrons. Make sure you're going through and making those changes. Again, this is perfect for sticking this into your IMTs, what we figured out from the previous lesson, or what we figured out for lesson number 10. All right, see, people also talking about what they are going to do for this lesson. So let me see you stick in there. What are we going to be doing for this lesson? Hey, Kaylee, what are we going to be doing for this lesson?
Do I share it out?
Yeah, go ahead and share it out.
I don't know.
Take a look at your objective on the slide.
We're trying to figure out if we can replace different molecules on the periodic table based on the
All right. Based on patterns. All right. So we need to be identifying some patterns on the periodic table. All right. 2 solutions to the problem of what might replace important molecules. So be sure at the end we're identifying patterns, and we're talking about patterns in the periodic table. That is a number of valence electrons. And also we're talking about those properties, those bulk properties, melting point and boiling point, and states of matter. So if you're not mentioning those bulk properties, melting point and boiling point, and states of matter, you will be missing the mark. Also, identifying whether they're symmetrical, asymmetrical, polar, and the type of bond, you will also be missing the mark. So when they say patterns, please look to your academic vocabulary for those patterns. According to the periodic table in column, just reminding you that every time you respond, you want to be referencing your chemistry Bible, your periodic table. So in the Google Doc, I want you to pull up a Google Doc and draw a Lewis dot structure for phosphorus. Again, make sure your periodic table is open, up, and ready. Draw 1 chlorine atom and then put them together to make a compound. This is in preparation for you to have a model ready for lesson number 11. So open a Google Doc. Make sure that doc is stored in your chemistry drive. Pull up your Lewis dot diagram periodic table, also stored in your drive or found anywhere on Google. Draw a chlorine atom and put them together to make a compound. Lock-in responses. Let me draw for that. If you would like to draw this in your notebook, but remember, you're gonna have to transfer this into a digital format. I'll give you a minute to do that. All right, remind us, what group is phosphorus found and how many valence electrons? Drop that in the chat. What's the group? How many valence electrons? Group number blank, number of valence electrons blank. Let me see us in the chat. Let's come to a consensus on this. Thank you so much, Jacqueline. Jacqueline is attending. All right, group. Thank you, Edgar. Yes, Trinity. Yes, that's correct in the Google Doc. All right, Kaylee got 3 responses so far, 4. Thank you, Isiel. All right, we got 20.
Mr. Sane.
Yes, go ahead, Kaylee.
I think Trinity was asking how are we supposed to draw on a Google Doc because I don't know how to either.
Oh, so there is a feature, I think it's called Kami. In period lesson number 2, we worked with Kami. You can use that. So if you've not registered for it, then you won't have it, but we practiced using Kami before. But if not, you can always draw on your notebooks and then upload. That's another way. That's a workaround. All right, Edward has responded. Thank you. 21 people in this chat. Let me see all 21 responses. But so far, Edward, what group and how many valence electrons are we saying so far in the chat? What's the group consensus?
Group 15 and 5 valence electrons.
Thank you so much. Thank you for responding, Debriana and Trinity. Okay, let me see you start referencing this in your peer deck. So on opening back your responses, unlocking in your Google Doc, draw the Lewis dot structure for phosphorus, chlorine, put them together. What do you get? Did you get something like this? So take a look at phosphorus. You referencing the octet rule and that we need 8 electrons around every element to make sure that they're stable. That 8 number of electrons rule for elements to become stable. We have 2, and remember your bonding stick is 2 electrons. So 2, 4, 6, 8. Phosphorus is full, phosphorus is satisfied. Look at chlorine, 2, 4, 6, 8. So chlorine is satisfied with 8 electrons. Look at this other chlorine, 2, 4, 6, 8. 8 chlorines, 8 electrons surrounding this chlorine, 2, 4, 6, 8. 8 valence electrons surrounding that chlorine. All right, and we know that there are 3 chlorines and 1 phosphorus. Phosphorus has 5 electrons. And if I do my math, if chlorine has 7 valence electrons, 3 7s, 21 plus 5, that's 26. I should have 26 valence electrons total. So let's count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26 electrons. Or did you get this? This is another possibility where phosphorus shares every single electron it has with more chlorine atoms, and so it's able to form more bonds. So I bet you were saying, okay, all right, now you got me. So phosphorus is able to share electrons with 2 more chlorine atoms. Notice these 2 lonely electrons at the top of phosphorus. It's able to share each of those electrons with another chlorine. And each chlorine needs only 1 valence electron to complete the outer number of 8 valence electrons. All right, so if you get either, you will be correct. So the question is, can we substitute for arsenic for phosphorus? That's one question. How does this work? And I'm hoping that you're going to be using this term according to the periodic table. How does this work? What might this work? What might not work if life does this? what's probably wrong with arsenic? In other words, that we would not want to use arsenic in this life on Earth. All right. We have 3 responders in Peer Deck so far. Pardon me. Go ahead and respond with, thank you so much, Sapphire, using the stem according to the periodic table. All right, referencing the column. Veronica has referenced arsenic and phosphorus. Make sure that we're using P as an uppercase representing the element phosphorus. Trinity is referencing column 15. So far, almost 100% using sentence frames. Please go ahead and use the sentence frame provided. Almost 100% using uppercase. Thank you so much, Kaylee, Isiel, Jacqueline. All right. We have 9 responders so far. Still looking for 9 more to join in. Thank you, Jacqueline Lopez, for responding in Peer Deck. Looking for 3 sentences. Still waiting for Debriana, Antonia, Edward, Jacob, Jacqueline, Emily, Edgar, and Eric. Want to make sure that we're responding to these 3 prompts, giving you 6 minutes. Three sentences, 3 different thoughts. All right, so we got some good responses. Hey, Jacqueline Padilla, could you share with us, excuse me, what elements are we trying to substitute?
Phosphorus.
And what are you trying to substitute in its place?
Arsenic.
Thank you so much. Making sure that we're sure what elements we are substituting. Nice. And could you give us a symbol for arsenic?
Not a symbol.
Yeah. So you got it there. What's that symbol?
AS.
And for phosphorus?
P.
All right. Thank you so much. All right. Go ahead and make those changes, guys. Thank you so much, Jacqueline Padilla. All right. Looking at your statement. And how might we do this? Hannah, noticing that you're referencing your periodic table to answer the second question, could you go ahead and state for us what column are we finding phosphorus and arsenic? Hannah going once, Hannah going twice. Hey, Kaylee. What column are we referencing phosphorus and arsenic?
15.
And therefore, how many valence electrons?
5.
Yeah, thank you so much. And Then, hey, Veronica, tell us why would we not want to use arsenic? Edgar, why would we not want to use arsenic? Make sure that we're looking at our class responses here.
Because it's pretty toxic for life.
For all life, for us, for animals. Let's think. Let's apply this to real life now. That's how you get a 4 out of 4. For who? Toxic for who? Or what?
Like plants or something.
All right, plants. What about you and I? All right, so let me see you referencing that. Give me 30 seconds to get caught up. Make sure that you have 3 sentences, at least your second sentence. And some of you put your first referencing the periodic table, column number, number of valence electrons. All right, Ashley, looking at your responses, could you go ahead and share with us one thing that you'd like to include from your student responses into your peer deck? One thing you'd like to include into your peer deck response. Go ahead and open and share. Hey, Jacqueline Padilla, go ahead and one thing that you're seeing in the student responses that you'd love to use in your peer deck response. One thing that's different.
One thing that's different is
And leaning a little bit more into that mic. And you can start your sentence off, I like that, and state the person that wrote it and state what they said. Give them make them feel good. They did something well.
I like what Veronica said, because she said why we wouldn't substitute it, because phosphorus is more toxic, so it's more toxic to life.
Thank you so much. Let me see you include that. And I see Edgar adding more to his response. Make sure that we're coming back to these responses when we're answering our exit tickets. Some of them are plug and play. We're working towards that exit ticket. Some of them, we just need to read it back and remember what we learned in this lesson. All right, giving you about 15 seconds more before we move on. It's now 9 o'clock. Jacqueline is extending her response in peer deck. Thank you so much, Jacqueline. All right, Donna's 3 sentences, periods ready, showing 3 different thoughts. Everyone responding, almost everyone using the sentence frame according to the periodic table, stating the valence electrons. All right, moving on to slide number 15. In slide number 15, again, there is an opportunity to use a sentence frame according to the periodic table. So what is the most important molecule that we've studied that is important for life? Do you think we can find a substitute for this molecule? What should we look for? 3 different sentences, 3 different responses for, let me see you guys attempting 3 different sentences for at least a 2.2. When they're correct, it's going to be, once you've attempted and it's, some correct, some parts not correct, 2.8, using all vocab terms correctly, all sentence, using the sentence frame, that's a 3.4. Thinking outside the box, 4.4. All right, so make sure you're responding in Pear Deck. What is the most important molecule that we studied that's important for life? All right, we got 1, 2, 3, 4, 5, 6, 7. Let me see the top 10. Kaylee is number 7, Edgar number 8, and coming in at number 9 is Jacqueline Padilla, and in the top 10, last person in the top 10 is, all right, the most important molecule for life. Thank you for that sentence frame, Jacqueline Padilla. With that, let me have the other 9 joining in. Hannah using uppercase and the sentence frame, the most important molecule that we've studied. Isiel, in my opinion, the most important, using an uppercase. I think the most important molecule is, hey, Isiel, open mic and share out. What's the most important molecule that we have studied so far, in your opinion?
I said the most important molecule that we studied is water and oxygen.
Okay, all right. So which one is more important? Water.
Oxygen.
All right. Do you think all organisms need oxygen to live?
Somewhat.
Somewhat. All right. So calling on Donald, I want you to go ahead and drop in the chat what you think. Which one is the most important and why? Just copy a piece of your response there and tell us why. And in the meantime, asking which one is more important? Which one can living organisms do without? Which one can we not do without? Which one has we been studying the most so far? Is it one of those molecules? Which molecule has been so important for life that we've been studying so far? Isel said somewhat. Are there some organisms that can survive without oxygen? All right, looking in the chat. Water, because literally everything needs it. Everything. Does everything need oxygen? Are there any organisms that can survive without oxygen? And if that's so, let's put this to a vote. Oxygen or water? What is more important for life in the entire planet? Put that in the chat. Which is more important for life on the planet, on all planets where we expect life? All right, thank you, Kaylee. Thank you, Donald. Thank you, Veronica. Yep, Jacob. Thank you so much. All right, we have 21 people in this chat. Go ahead and respond in the chat. And to help you respond to this question, take a look at what I'm presenting right here. Hey, Kaylee, could you read this out for us?
The picture,
Yeah, what you see on this picture.
I think that's, I don't know how to say that. Anaerobic bacteria.
Anaerobic.
Anaerobic bacteria do not require oxygen for growth.
You're lying. This is alien stuff, right? Or is this Earth?
Girl, I don't know.
Okay, so are you in denial? This is on Earth, guys. Anaerobic bacteria, they do exist on Earth. We do have bacteria that can exist without oxygen. So in the chat, what do you think? If you post it in the chat, tell me one more time. Do you need oxygen? Do you need water? What is more important? Drop that in the chat. Thank you, Trinity. Yep, Donald restating basically, yep. We need water and plants need oxygen for breath. So water. Thank you so much, Jacob. Go ahead and respond in the Pear Deck. Make sure you're responding appropriately. Jacob has stamped it for us. It's water, definitely. So we do need all right, Sapphire. So go ahead and stamp for us. What do we need the most in order for life? What do we look for? Sapphire, are you there? Edgar, go ahead and name that for us. What's the most important molecule for life?
Oxygen,
You sure about that?
water.
You sure about that?
Okay.
So remember, there are some organisms that can survive without oxygen. All right, so make sure you're responding appropriately. Calling on Trinity. What's the most important molecule for life?
Hydrogen.
Hydrogen, found on the periodic table, that's an element. Take a look further down in your response. I see you put it there. Molecule. Hydrogen is an element, very good. But which is the most important molecule? We've just stamped it. Jacob, which one did we said is the most important? And we can only pick one that we've studied so far.
I said water.
All right, thank you so much. Make sure that we are responding appropriately. Still waiting on 7 others. Most important. And then responding to the next set of questions. So that's one sentence. We know that water is the most important. Do you think we can find a substitute for this molecule? And what should we look for? So 3 sentences. See Jacob using the term substitute. Trinity using the term substitute. All right, so we're looking for a substitute for water. The focus is on water. Do you think we can find a substitute for water? Hey, Jacqueline Lopez, what do you think? Do you think we can find a substitute for water?
I think that it would be really difficult to find one, but maybe there isn't.
You're thinking there is. Hey, Trinity, what do you think?
I said that if we find a substitute for this molecule, we should look for elements like hydrogen and oxygen because that's what makes water.
Oh, okay. I wonder if we can sneak that term in according to the periodic table. If we can find substitutes for hydrogen and oxygen, what would those substitutes be? Could we use that term? According to the periodic table. So driving that home one more time, make sure, let me see you using that phrase, that sentence stem, according to the periodic table. If I were to look for a substitute, what would those substitute be? Kaylee mentioning the term oxygen. Trinity has mentioned the term oxygen and hydrogen. According to the periodic table, thank you, Trinity. You guys respond way more better in your peer decks than you do in your exit tickets. I wish you would come back to your peer decks and use your responses here to respond to your peer deck. All right, so what elements could we look for to replace hydrogen and oxygen? Hey, Veronica, if we were to look for a substitute for hydrogen and oxygen, what would we look for?
Sorry, what was the question again?
Yeah, we're now talking about what if we were to look for substitutes for hydrogen and oxygen? What would we look for?
I guess you would just look if you're like trying to like replace like hydrogen and like the other one. I think you would just find what like makes like find the elements that make up hydrogen and was it oxygen?
Oh, you're looking for elements that are similar to hydrogen and oxygen. Where would you find that? Can anyone open mic and help us transition into the next slide? Where would we find those elements?
It would be in the same column.
Nice, in the same column, where? What's our chemistry Bible called?
The periodic table.
Thank you so much. All right. All right, giving you 15 seconds to finish up that thought. Make sure you pull in some good ideas and responses from the peer deck, from your student responses. 10 more seconds. 7, 6, 5, almost 100% ending with periods, showing grammatical correctness. Using 3 sentences. If you're not, you're gonna have to come back and make those changes. All right, moving on to the next slide. Here is now our opportunity to work in groups, and this will be group work requiring you guys to respond in your groups, to share out ideas, popcorn all around, asking questions, putting ideas. We're going to be putting our ideas down in our Jamboard, generating groups, copying groups, dropping groups in the chat. All right. Go ahead, Kaylee, list the group members in your group, and that's group green.
It's me, Veronica, Donald, Edward, and Stevie.
All right. And in group two, list group members for group two, Isiel. Isiel, Antonia, go ahead and list group members for group two.
I was supposed to list him.
Yeah, go ahead and list them off for the rest of us to hear.
Antonia, Eric, Jacqueline, Trinity, Cynthia, and Ashley.
All right, thank you so much. And group three, the first member, please go ahead and list those off. Debriana, go ahead and list those group members off in your group.
Jacob, Jacqueline, Stefan,
All right, thank you so much. All right, my group, green group. So this is a group green. Groups will investigate these two properties for the top choices, the two top choices of compounds and water. All right, so you're gonna head to period number 1, group on your discussion board. So click that and it takes you to your Jam board. Scroll on over to slide number 11. Here we have group 1. What elements could replace hydrogen? This is group 1. Group 2. Elements that could replace oxygen, giving you the opportunity to join in. And group 3, you'll be working on properties of water. So I want you to identify as many elements as possible that can be used to represent hydrogen, oxygen, and water. And then you're gonna be picking the top 2, only 2. And then I'm dropping in the chat your group links. You'll be working in those groups for about 15 minutes tops. Once you're done, during that time, you will be putting sticky notes into Jamboard. You will use 1 sticky note per term. Once you've used those sticky notes, each person will make sure that they're getting their thoughts in, and then you're choosing the top 2. Dropping those links in your Google Meet. Once they're in, I'll silence my main group and I'll meet you into your small groups. So first group, group 1, 2, and 3, those are your links. Silencing main group. And head on over to your small groups. Once you're there, Kaylee, Isiel, and Debriana, you guys will start and share out, and then popcorn until everyone has gotten an opportunity to share their thoughts. Make sure you're referencing the periodic table. There is one already on Jamboard here where you see me circling with my cursor or my mouse. Make sure you're using the sticky note per term and put your name on it, and then we're gonna have you guys pick the top two. All right, so before you go, let me ask you guys, Jacqueline Lopez, what are we about to do?
We're gonna go into groups and then we're going to research whatever topic we have.
Thank you. Who will go first in your group, Kaylee?
I think I do.
All right, and then who goes next?
Veronica and then Donald.
Thank you so much. All right, Jacqueline, Sapphire, who goes first in your group? Emily, who goes first in your group? Job, who goes first in your group? Thinking that those people are not here. Let me see. Hannah, can I have you hop on over to group 3? Hannah, could you just open mic and confirm that you heard? Hannah, could you hop on over to group 3?
Okay.
Thank you. All right, silencing main group, heading over to your group link. Get your ideas down on your sticky notes. Stick them into Jamboard. Yeah, guys, go ahead and use the symbols on the periodic table. You don't necessarily have to use the full name. All right, go ahead and use those symbols. Make sure you're stapling and identifying the top two. Next person in your group, follow that list. We have 10 more minutes. Thank you, Group Oxygen. Group Oxygen's put some ideas down. Let me see those on individual sticky notes. Let me hear you talking about the best option. Using the chats, using the open mic. Go ahead and make those suggestions. All right, group oxygen, make sure you're picking the top two. Thank you, group water properties, suggesting your first. Group hydrogen, go ahead and suggest your top two. Put them on the jam. Oh, look for Jamboard. So click that link in discussion board 1. That's how you get there. Got 4 more minutes. Hey, Angelo, welcome in. All right, Angelo, join the peer deck. We have 3 more minutes. What we're doing is working on that investigation. I want you to hit discussion board 1, PD. I'm gonna drop you this link. Join peer deck NXQBJU. We're identifying substitutes for the element hydrogen, oxygen, and properties of water that we should be looking for in other elements. Just a reminder that molecules are not found on the periodic table, only elements. So make sure that you're looking for elements within your group.
Hey, Mr. Singh. Mister, what slide do we do for hydrogen? Like, what slide on the, whatever it's called, the jam board?
Game will not be on it anymore after
Hey, Veronica, we're on slide 3.
Okay.
All right, guys, so let's start muting our small group and heading back to our whole group. Be prepared, group leaders, to share out. So that's Veronica, I think Debriana, and Isiel. So Kaylee, when you're, Kaylee, Isiel, and Debriana, when we're back in the whole group, I want you guys to present your top 2 elements and properties.
Do we go right now or when we're all back?
All right, start heading back. And I see that you guys are ready with your 2 elements. Group number oxygen, please make sure you have your top 2 elements. Group hydrogen has their top 2, and group properties of water, they have their top 2. Tell us why, make sure you're ready to tell us why those top 2. Thank you for using sticky notes, dropping those ideas in. Okay, guys, so for my group, so looking at your pair deck, group number 1, could you tell us your top 2 and why those 2?
We said lithium and sodium because they're both in the first column with hydrogen and they both have 1 electron.
All right, let's slow down for a sec. Nice, all right, so sodium and lithium.
Yeah.
Nice, and because they have 1 valence electron, I'm hearing, but why not potassium?
You said choose 2, so we didn't do 3, we chose 2.
All right, so there's no reason why you didn't choose potassium. All right, thank you. Group number 2. Give me a second, let me quiet down this screaming baby in the background. All right, whoever is doing that, can we just pause on that? So group oxygen.
We said sulfur and Se. I didn't know what that meant.
Okay, selenium. Why sulfur and Se? Why not tellurium?
I don't know, to be honest. We barely talked about it, but they were both in the same column as oxygen.
All right, in the same column. And then how many valence electrons?
They have 6 valence electrons.
Thank you so much. And group properties of water. I see you have 2 properties there. What were the possibilities and why did you choose those 2?
I'm really not sure.
All right, what are those properties? Let's answer that first. And what were the choices you had?
We had polar and surface tension.
Any others?
No.
Okay, so you guys chose polar and surface tension. And so let's see. So you're saying that if we look for those properties, you're saying that we definitely will find life, surface tension, water?
I can help her out.
Yeah, go ahead.
We chose that. We chose polar because it creates the electricity. The surface tension is apparent because there could be like animals on the surface of water.
Oh, all right. Okay, thank you so much. All right, so let's move on to the next part of our lesson. And we took a bit of time, so pardon me if I kind of take about 10 minutes of your asynchronous time, just giving you a heads up on that one. Let's see if we can get through these slides very quickly. So which elements do we think would be best substitute for hydrogen? We said that that was lithium and sodium. We said which one was we could substitute for oxygen. We said sulfur and selenium. And then the properties are polar and solubility. Now let's take a look at some specific properties for lithium oxide Li2O. And we've drawn this before. I hope you recognize this molecule that we've drawn this before when we're working with ionic compounds. Here is H2S. I want you to look at the elements that are within H2S, and water, of course, H2O. Look at the melting, the properties there, and I'm gonna ask Edgar, could you list those properties that we see in the first column?
All of them or one?
Yeah, go ahead and list them all.
Melting point, boiling point, ability to act as solvent, conductivity, shape, type of bonding, and I don't know what the other one says because the pair is blocking it.
The pair, oh, you can see the pair?
Yeah.
Thank you for letting me know. I never thought that you guys could actually see from this end. So it's safety, toxicity. All right, so let's model here safety and toxicity. So if I were to compare the similarities and contrast with the differences, I would say, looking at water, I know that water is not toxic, it's safe. But if I were to look at hydrogen sulfide, it's flammable and highly toxic. Oh my gosh. And then lithium oxide doesn't seem that bad. It only causes, it's caustic. That's the opposite of acidic. And trust me, caustic still burns and it causes, so it does cause burns. But it doesn't sound, so we know that in the similarities, they're both bad. But if I were to talk about the differences, I would say that hydrogen sulfide is much worse than lithium oxide when compared to water. All right, so the similarities are that. So let me hear you starting your sentences off. The similarities with toxicity for water is that it's not toxic. But there are no similarities here with water and lithium and hydrogen sulfide. The difference is it's these molecules are toxic. So I want you to do the same, and I want you to compare the similarities. Molecules that are similar to water in terms of melting point are molecules that are similar to water in terms of a boiling point are, or molecules that are different in terms of melting point are, and go ahead and state those specific differences and similarities. So looking for you guys to state this in Pear Deck using those sentence frames provided. Veronica, the similarities. Jacqueline, some similarities. Trinity, I noticed that they are, thank you so much, Trinity, all so far using uppercases. Hannah is now the 6th person using uppercase. Debrianna, 7th. Some similarities are, thank you, Edgar. Trinity using the term differences. Someone has mentioned the property. Make sure you are mentioning the property shape. Someone's used the term melting and boiling points. And remember those numbers, when they're negative, that's very cold, that's below 0 degrees Celsius. And remember, 0 degrees Celsius is where we have water freezing. Just to give you an idea of what a negative value means in degrees Celsius, 100 degrees Celsius means boiling for water. What does that mean for these properties? Still, a step further would be these properties are at room temperature, they would be a solid, liquid, or gas. Make sure that you are using those academic terms that you wrote in your notebook. All right, someone using the term flammable. the property flammable, ability to act as a solvent. Someone has mentioned bonding type. Thank you so much, Donald. Someone has mentioned conductivity. Are they similar or different from water? Remember, the focus is on water. So how are these compounds similar or different to water? Aziel has mentioned the two molecules, lithium oxide and hydrogen sulfide. All right, good, Angelo. I think the difference is with these, thank you for using the sentence frame, referencing the properties. Be very specific. Can I tell you, you need to come back to this slide in your exit ticket. All right, so looking for 7 non-responders. Let me see you jumping in on this chat. Eric, are you still there? Emily, are you still there? Jacob, Ashley, Edward, Kaylee, and Antonia. Checking in to see if you guys got dropped from the chat. Hey, Emily, let me see you jumping on Peer Deck. As it is right now, we need to make sure we have 100% of us responding in Peer Deck. So far, I see the rest of us typing in. Let me see you start typing in Peer Deck. And we're on slide number 7. All right, let me see if I can try to call in and get some support for you, Emily. Ashley, Edward, if you're there, respond. Jacob, if you're there, please respond. Eric, if you're there, please respond in Google Meet so I can give you some support. Thank you so much, Sapphire, indicating some similarities and differences there. All right, we are a little bit into asynchronous time. I want to give you the opportunity to respond to these, identifying some similarities. Let's go ahead and name some. Hannah, could you go ahead and tell us one similarity and one difference that you notice between water and these molecules?
Yeah, just give me a second.
Yep, sure.
Oh, that it's the shape is bent.
Oh, I'm sorry. Go ahead.
That the shape is bent.
Ah, the shape is bent. So are they both bent, all bent? Some are bent, only one or two are bent.
All of them.
Ah, there's some. Thank you. Give me one difference.
Water is not toxic, it's safe.
All right, water is not toxic, it's safe. Thank you so much. Fire, give us one similarity, one difference that you noticed in properties. Popcorn, Kaylee. One similarity, one difference.
one similarity is that they're always, like, when it's lithium or hydrogen, there's always two, like Li2 or H2. So there's always like two electrons that are being created. Oh my god.
Thank you so much.
It keeps echoing.
I'm sorry, I didn't get that last bit.
It echoes when I talk, so I get confused because I can't.
All right, no worries. No worries, it happens. Trinity, I see you have some specific ideas there. Could you share with us what did you find similar and what did you find different?
I said that they are all bent and all of them can conduct electricity. And the difference that I found is that they all have different melting and boiling points. And water is like safe and not toxic. H2S is flammable and Ally 20 can cause burning.
All right, thank you so much, Trinity. Veronica, I see you have something again about melting point. Can you also confirm what Trinity said? Confirm anything about boiling point?
So for the melting point, I noticed that the first property was like, and water were like positive, but H2S was like negative for the melting point.
That's very cold, wasn't it?
Yeah.
What about the boiling points? Are they similar or are they different?
Well, for the boiling point, it's positive for the first property and water, but for H2S, it's negative.
All right, thank you so much. All right, so we're referencing or CLO, we're using the terms melting and boiling point. So definitely you want to mention these two properties in your exit tickets. So thank you so much, Hannah, Kaylee, Trinity. Let me see who else has mentioned melting and boiling point. Edgar, I see Jacqueline Lopez has mentioned melting and boiling point. Just want to call your attention to that. Donald, thank you so much. If you have not, I want to see you coming back to this slide and using those, make sure you're finishing this up and then mention these in your exit tickets. Also seeing Sapphire, thank you so much for identifying those differences in melting and boiling points. Now, again, remember, whenever you're responding to the slides, be prepared to use the term, the sentence frame, according to the periodic table and referencing a column. Explaining the differences. How can we explain the difference for both molecules in terms of the elements that make up the compound? How can we explain the differences for both molecules in terms of the strength of attraction between those molecules? The driving questions. What substance could we look for that could replace liquid water on other planets? So I'm gonna put you in student mode and I want you to suggest one of those two molecules. And then where should we look for them in the solar system? All right, so think about all those planets, where we are, where's the sun, and where would you look for those in the solar system? So if you want to take a quick look at the solar system to remind you about some Earth science we learned back in 8th grade, please do so. I'm going to be putting you in student mode. So you should be able to flip back to slide number 7, where we had that table. And you should be able to move back. So 2 people have gone back to slide number 2. And now we're slide number 8. Let me see you responding in Peer Deck using those sentence, responding to these words, using the word bank: metal, non-metallic, ionic, covalent, intermolecular force, strong, weak. So mentioning whether those elements are metallic or non-metallic. Mentioning whether the bonds are ionic or covalent. Mentioning whether the intermolecular forces are weak or strong. And then you also want to mention whether these forces of attraction are weak or strong. Are the molecules polar? What is a melting? And if you want to say boiling point, you can. And state whether these are going to be solids, liquids, or gases in the solar system. Eric is responding in Peer Deck using an uppercase. Thank you so much. Giving you some silent feedback.
Mister, I don't understand the question.
All right, thank you, Kaylee, for reaching out. All right, so what you're gonna do, you're looking at both molecules and you identify the elements within each molecule. For example, lithium oxide has the elements lithium and oxygen. You can, if you could chime in and tell me, what are those elements in hydrogen and sulfide? Could you tell me those two elements?
What do you mean? You just said it. You said hydrogen.
And
And it's also
in sulfur. So I say hydrogen sulfide is a name. So one of the element is hydrogen and the other is sulfur. So they're talking about these elements that make up those compounds. So explain, how are they different? According to the periodic table, where will you find these elements? What will be, are they metals or non-metals? Will they form ionic or covalent bonds? And then how can we explain both differences for both molecules in terms of attraction between the molecules? So tell me the force of attraction is going to be strong or weak. Why? Are these, and then look at the melting and boiling points like we did. If they have strong intermolecular forces, will they have high melting points? Will they have high boiling points? Or if they have weak intermolecular forces, will they have high melting points or low boiling points? Will they be a solid, liquid, or gas? And then you're gonna tell me which one would you use to replace water? Where would you find this in the solar system? Where should we look for this in the solar system? Should we look closer to the sun or should we look more further from the sun? Closer to,
Okay, thank you.
no problem. All right, guys, make sure you're going to Schoology and opening up today's student activity sheet for lesson number 11. You will also be submitting this. Once you open this, you want to go to your slide. Slide number 7, filling that information for you. This is given to you in the interest of time. Usually this will be an internet search. And you're gonna need this for slide number 9 so that you can respond to the prompt on slide number 9 inside of your student activity sheet. You will not be required to draw this table out. What you will do is fill out where these planets are. Are they in the Goldilocks zone or are they outside of the Goldilocks zone? You're gonna put yes or no. You're looking at the temperatures, the minimum and maximum temperatures of these planets. They're already given to you. And then you're gonna tell me, are these substances gonna be solids or liquids at these temperatures on these planets? All right, so giving you some feedback right now, checking in on you. Again, taking a little bit more of your time because we need to get through these slides.
Hey, Mr. Singh, are we gonna do the lesson 11 for exit ticket?
Yes, we are, and we want to try to get through to that right now. So gonna bring you back to this slide number 8, checking in. So taking a look here at your student responses. All right, Trinity, could you share with us what we figured out so far?
We figured out that alloy 20 has the elements lithium and oxygen, and it is ionic. It is a gas and it has a strong bonding. H2S is an element, hydrogen and sulfur, and it is polar, and it is a gas. And water has the elements hydrogen and oxygen, and it is also polar and a liquid.
All right, could you slow down and tell us, why do you say lithium oxide is ionic? What terms can we use to describe those elements?
I don't know, Mister just said in the last slide that it was ionic.
Okay. All right. Looking up in your, make sure that we're using those terms from our academic vocabulary. We need to make sure that we're stating whether these elements are metallic or non-metallic. So go to the chat. Let's see if we can identify whether these elements are metallic or non-metallic. Lithium, drop that in the chat. Is it metallic or non-metallic? Lithium, Li, metallic or non-metallic? All right, make sure you're mentioning that in your post, guys. Metallic or non-metallic, you must be stating whether it's ionic or covalent. And Trinity has modeled for us that we need to be referencing the melting points and boiling points. Once you're done, you're moving on to what about the solar system? In your student activity sheet, again, this is your table. You want to make sure that you're grabbing those tables from Schoology. Can someone tell me if they're able to open that table in Schoology? All right, thank you so much, Isiel, indicating that lithium is metallic. Hey, Isiel, are you able to open your student activity sheet?
Yeah, I did.
All right, cool, thank you. So it is available. Putting you back in student mode. Cheering you on, I'm just a cheerleader on the side. When you get to your slide number 10, the last slide, what you figured out, you want to stick that into your IMT for lesson number 11. List some things that matter to life that exists on other planets. What would we figure out next? Go to the driving question board. Hit that link. It takes you to your driving question board. I want you to put the next question you have that you mentioned in your peer deck and put your name there. Tell me, is it going to be your investigation of water, plants, weather, space, alien, planets, other life forms, or create a new column and stick your question, put your name on your sticky note. One last thing, the things that you need to complete for your asynchronous, make sure you're looking at, today is the 7th, so let's look, today's date. Your exit ticket search for life, but more importantly, make sure you're doing that search for life ed puzzle for lesson number 11. And submitting that student activity sheet. Your ed puzzle is graded. Please make sure you're answering the 4 questions with fidelity and answering them correctly. The last 2 I'll grade, and then proceed to your exit ticket. That's it. Make sure you're submitting your IMT, exit ticket, and ed puzzle. And your student activity sheet. Please do not draw that table down in your notebooks. You don't have to.
Okay, Mr. Singh, so we have to do the exit ticket and then the ed puzzle and then slide 9.
Yeah, that will be it. Your exit ticket are 4 questions. Make sure you're going back to your peer deck responses. I can't emphasize this so much. Go back to your peer deck responses and make sure that you're referencing the periodic table and the column number that you get your information from the periodic table. That's it. That's all I have for you. I'm going to be silent in the background, grading your ed puzzle.
Mister.
Yep, go ahead.
The ed puzzle ain't working.
All right. Is there anyone who's going to give me the link to the ed puzzle as well not working? All right, thank you. Will do.